Okay, hello everybody. Today we are covering installation. This is going to be a um, fairly thorough section that is condensed down into probably a pretty quick time period. Number one, I don't have a lot of people that are live, so there probably won't be many questions. And number two, I don't want somebody having to watch a 2 hour long Loom video and losing all interest in it. So, to start with, we're going to talk about the different methods of mounting. I think most of you are already familiar with these at this point in time, probably. The one that I want to talk about is building integrated. That is referred to as BIPV, building integrated photovoltaic. And that is basically where you are replacing part of your structure with panels. Think of it as if you were in Alaska and you built your walls with solar panels. I know it sounds crazy to say, but the sun throughout the summertime, it never sets and it rotates around you. And so all four of your walls would actually be exposed to sunlight. So that'd be an example of building integrated photovoltaic. Roofing material is oftentimes the most common, and we are now getting to solar windows that will allow a reduced amount of light in and use the rest of the energy to produce electricity, therefore lowering the heat load or heat gain for high-rise buildings. So here we see examples of roof-mounted. It is the most common for residential applications. Roof-mounted solar panels are. Pole-mounted. There's a couple of types of pole-mounted, and pole-mounted is becoming very, very popular for commercial and some for utility scale. Ground mounted, slightly different than pole mounted, but very, very close. You have multiple attachments to the earth. Ground mounted is definitely the most common for utility scale, and it's also pretty common for commercial applications. And then building integrated PV. So I have installed some BIPV. It was tied into the roofing, the metal roofing. And you can see the images right here. We built a net zero home in Georgia, and we did BIPV into the roofing. So the different roofing styles are: we have adjustable or fixed rack mounting. The adjustable rack would allow you to have either a summertime setting or a wintertime setting, possibly a year-round setting in between. And they could have perhaps a morning setting and an evening setting. In other words, if the axis was north and south, you could tilt your panels one direction for morning, flat for the afternoon, or west facing in the evening. But that doesn't mean that they adjust themselves. That means that the owner can adjust them. If you have ever been on the top of our Seeds trailer here at Crowder, you can go look at an adjustable rack mounting for a roof. You also have standoff and ballasted. By this point, you should understand what those two are. The ballasted we've actually installed and taken down. That is where weights will hold the panels down. And normally a 5-degree or a 10-degree roof slope is all that you can install a ballasted system on. Now, when you're actually attaching to a roof, you are normally at least 4 inches off of that roof, hopefully no more than 6 inches off of the roof, or it changes your wind loading. Heavy-duty rails allow you to have attachment points that are farther apart. Light-duty or regular-duty rails, you need more attachment points. So it's kind of a trade-off. The light-duty rails, less material, cheaper price, more attachment points, more labor, and more materials. So you have to kind of understand the concept of the whole picture for estimating the cost of a project to determine which of your rail mechanisms is the cheapest for your project. There's also two main types of clamps that hold the panels down to the racking. There is a mid clamp and an end clamp. The mid clamps fit between two panels, holding both panels down. An end clamp only holds one panel on one side of the clamp down because it is at the end of a module run. You also need grounding clips. the grounding clips oftentimes are built into these clamps. Not always, but oftentimes. And then you need splice kits or rail splices. And these are specific metal moldings that will attach one section of your rail to another and basically create a strength parameter as though the rail was continuous. So if the rules say you need an attachment point every 4 feet and you cannot overhang past 12 inches from an attachment point with your rail, you could actually put the rail splice right in the middle of 2 attachment points, so 2 feet and 2 feet, and still be into the code that you're looking for. Mounting brackets, guys, this technology changes annually. I can tell you that Unirac and Iron Ridge are the 2 main racking distributors in the United States. They're the 2 largest. There are other ones, but currently they have some of the best technology. Once again, as I have said in the past, excuse me, I highly recommend that you let your supplier, use an example of Unirac, know what type of roof material you've got. Hey, I've got 3 tabbed asphalt shingles. I'm installing on this roof pitch. Sell me everything that I need for this many panels mounted in landscape or in portrait in series, and this many runs of those panels in landscape or portrait. You know, the greatest thing is just to send them an engineered drawing that you use Aurora to make, and they will then provide all of the materials that you would need. Aurora also may have estimating tools to tell you how many attachment points that you need using Unirac, because Unirac works with Aurora, and all of the equipment that they provide should be available in Aurora for you to determine the amount of materials and the materials that you need. ClickSys is a system that was popular about 5 or 6 years ago, and basically instead of having racking that would bolt into the attachments, it actually had racking that would click into the attachment points. It made it very quick. It made it kind of easy, I guess you could say, for adjusting slightly one way or another. Grounding modules are very important. You will either need to have a grounding clip for each module, grounding that module to the module next to it, or your mid clamps will need to have ground clips built into them. And then at the end, you will need to have a lug. I do not require you to understand this term of a weeb lay-in lug. However, the rail oftentimes needs to be ground off. You'll need to take a grinder or a file and grind that rail down to make sure that any protective coating that is on the rail or on the side of the panel, for instance, is ground off. And then you will take this lug and you will apply lube, electrical grease, an electrical lube in between the lug and the metal so that you don't have any galvanic corrosion. In other words, the corrosion that develops from 2 different metals of different ionic capacities, basically. And then you will run a ground wire from inside of this lug to wherever you need according to code. Perhaps you need to go to its own separate ground rod and then tap from that own ground rod into the negative grounding system of the home. You'll probably need to run a conductor from here all the way to the inverter to make sure that the inverter is grounded also to the panels themselves. Sunframe, I don't even know if Sunframe is in business anymore. Again, and I show you guys this stuff because this is what I created years ago, and that was what was popular then. I've really found it's not even worth my time, the hours and hours and hours it takes each semester to update it, because when I teach you these individual types, it's going to change by the time that you're actually ordering this material. So I tend to teach you the 2 names of Unirac being one of the largest. They're probably one of the largest for ground mounted, and Iron Ridge is right there close behind. Here's another system that was more popular, a ballasted type system whenever before the EasyFoot. No, the EcoFoot. That's what we currently teach you guys is the EcoFoot system, and you've already gotten a mounting lab in the ecosystem. on pole mounted, there's two separate types of pole mounted. There's top of pole and side of pole. Top of pole is always better, in my opinion, because it will allow for much better tracking. On this top of pole, you can rotate this direction and this direction. So you have a 2-axis adjustment for all top of pole mounting systems. Side of pole is not the same. Side of pole, theoretically, you could swivel completely around the pole, but it's much harder oftentimes to adjust the angle of the pole or the azimuth of the pole. Theoretically, it's still possible, but I have found that top of pole is more expensive and much easier to adjust. Side of pole is cheaper, but a little bit more difficult to adjust. And part of the reason that I say that is if you loosen these screws up enough to try to change the azimuth angle, the weight of all of those panels now bears down upon you for most of them. And so oftentimes you end up needing some type of a stop at the bottom to keep all that weight from bearing down. And I just have not found that those designs are as good. Rapid rack, ballasted racking. EcoFoot is the one that I currently have, that I currently teach you guys. However, EcoFoot may be outdated already. What you should look at is what price is this going to be able to add, and add the labor into it. Because oftentimes the cheapest designs for materials are the most expensive labor to provide. And in the end, the labor ends up being more for these ground-mounted ballasted systems than the materials themselves. So commercial building integrated PV, I think that this is going to be a huge growing aspect in the future. Every company like La-Z-Boy, when they build a new building, is going to want to integrate PV into their roof for a couple of reasons. One, it produces power. Two, they have to put something up there anyway. And three, they get a huge tax incentive to do so that you wouldn't get from a traditional roofing structure. Again, a slightly different style, much less wind loading for a completely encapsulated system. It's a nice, sleek look also. RV mounting. Now, RV is an easy way that I used to explain it to students on trailers that need power, but this can be almost anything. I have seen a portable welder that had a battery bank, solar panels, and a welder built into the truck. And it was mainly for farm use only. You drive out to a farm, you do a very small amount of welding in order to get the equipment back to their barn, where they would then plug their truck in to a much bigger power outage. But they did the pricing, and to buy a generator that was large enough to run their welder, it was actually cheaper to buy a small battery bank, a small solar power system, and they could weld for about 20 or 30 minutes at a time, with the back of their truck equipment. And that would normally get them enough that they could then get their tractor, their farm truck, their trailer back to the shop. And then they would then plug that welder directly into the wall rather than the inverter. And then they would just keep their farm truck parked outside. It also ran winches. They had a crane on the back of this truck that was small, but it could lift equipment like the bucket of a tractor. And they powered those winches using the batteries that were on the truck and the solar power. RV is an easy way to explain it. Guys, every RV has a little silly generator built into it, like a 1 kW generator to run the lights, to run the refrigerator, and to recharge a small battery bank. A 1 kW solar panel system, that's like 3 panels. And so if you got a contract with an RV company that you were able to market and they made a little bit of money, you slipped them 10% on every system and they hired you to install RV systems, big RV centers like in Northwest Arkansas would probably be able to keep you busy almost full time by being able to advertise, hey, are you sick of hearing your generator run during the daytime? Let us put a 24-hour battery bank in and enough solar panels that unless you're running something other than your refrigerator, like if you're running your air conditioner, that's a whole different story. That's when that bigger generator gets kicked in. But otherwise, there's no reason during the daytime to be having to run those inverters. It's just a new marketing aspect of our industry. Attachment mechanisms. Okay. This is probably the most important section of this. For those of you who are not construction oriented and have not had construction classes yet, NABCEP is going to test you about attachment mechanisms for rooftop and for ground mounted. For attic access required, in other words, if you can get into the attic floor or the interior home ceiling is insulated so that you can actually see the decking of the roof. It will allow you to use a variety of other attachment mechanisms. Lag screws with blocking, J-bolts, a spanner, support rod and blocking. Attic access is not required for BIPV, for metal roof clamps, and for lag screws that attach directly to the trusses. The reason that we talk about metal roof clamps, many metal roofs are installed attaching only to the decking. It is not required to hit the trusses to attach that metal roof. If you are going through that metal roof into the trusses themselves, then you do not necessarily need to get into the attic to find to attach for a J-bolt or a spanner. If you are going through the metal roof into the decking without finding the studs or the joists, that's a whole different thing, and you're going to need more attachment points. All right. So let's look at blocking. To start with, a blocking support is if I have two rafters and I'm needing to put a lag screw or a lag bolt in between those two rafters. Here's a rafter, here's a rafter. I place a block between those two rafters. I put nails or screws in through the side of this rafter into my block, this direction and this direction. I then put my lag screw or my lag bolt into that attachment point. There are two ways to do this. One is to put your blocking in place and then use a stud finder to find that blocking and drill into that blocking. If you have metal roofing, a stud finder will not work. That means that you need to drill through the metal roofing first, then come back into the attic and put your blocking in the exact location that you have already drilled the hole through the metal roof. Order of operation. Shingles, you can put your blocking in, find your blocking, drill your hole. Metal roofing, stud finder will not work. You need to drill your hole. If you get lucky enough to hit the stud, great. You don't have to put blocking in. If you do not hit the stud, that is where you will need to go back in and put blocking in. A J-bolt is necessary if you accidentally do not hit the stud or the joist and you need to. Okay, in other words, you were right next to it. I just missed it. Crap, what do I do? Well, you're going to need attic access, and you need to put a J-bolt up underneath and then come all the way through. Still work, it will still seal up. Ideally, J-bolts are not used unless they are intended to be used. The intended use is that you go into the attic and you drill from the attic back out of the hole and up through the roof. The reason that you do that is because then you know that this hole will be lined up exactly with your roof rafter, and you don't have a worry of what if I was too far off one side or too far off of the other, and now I'm going to have to either wallow my hole out and make my hole larger, or I'm going to have to fill that hole, plug it, and drill another hole. So ideally, if you're going to use J-bolts, you are drilling from the inside of the attic out. All right, spanners. Spanners are most often used on commercial buildings. They span from one truss to another, or one steel beam to another, and then threaded rod called all thread penetrates all the way through the roofing material and then down into the spanner. This is common for, like it said, commercial roofs. Very, very rarely will you need a spanner for a residential roof. Normally, blocking it is what is done there. All right. Easy feet. This is a mechanism that basically has a layer of butyl rubber. Now, you need to know that term. You need to know it very well. Butyl rubber is also in our industry called monkey shit. And I know that that is a politically incorrect term. It is an industry term. If your roofer comes on and uses the job site and you don't know what he's talking about, like, hey, do you mean to put monkey shit in these holes? Yes, I do. It lasts about 50 years. It's some of the best the best roof hole plugging material that you can get. It is extremely sticky. It will ruin your clothing. It will ruin your glasses if you get it on your glasses. But basically, there is a layer of it on the bottom of the attachment point, kind of like a sticker. You peel off a plastic or a little coating on that, and then you stick it right onto your roof surface. You put your roof penetrations through that butyl rubber and through your easy feet or your attachment for your foot, and that butyl rubber seals up against that attachment point. If you drill an actual hole, notice there's no pre-drilling involved with these. The heads of these screws go right through the butyl rubber and directly into, let's say, your metal roofing. You're not pre-drilling a hole at all. All right. If you do pre-drill a hole, then you need to put either a roof-approved silicone or the butyl rubber into the hole before you insert your screw or your lag. In other words, the screw is going to take up a certain portion of that hole, but that butyl rubber or that silicone that is like a liquid is going to fill 100% of the cracks and crevices, and whenever it dries, it will create not just a waterproof, but also an airproof barrier that will prevent any moisture from finding its way into that hole and causing a leak. Now, I will tell you, at all costs, avoid tile roofs. They are the most labor-intensive and expensive attachment mechanism that I have ever heard about. I personally have never installed on a tile roof of any kind. I have advised friends in Pennsylvania about how to install, but theirs was a slate tile roof, not a terracotta tile roof. So I will highly recommend to avoid tile roofing, but tile roofing is very difficult because you have to remove the tiles. If you do so and you break one, you have to be able to find replacements that are exact. What if they discontinued this model of tile 5, 10, 15 years ago? These terracotta tile roofs last 50 easily 50 years. They have a 50-year warranty. They may last 100 years. Some structures in Southern California and in Mexico could well be over 100 years with these terracotta tile roofs. So you need to, before you ever even accept the job, make sure that you can get replacements for these, because the chances of you breaking one is probably greater than 50%. Because as you're drilling holes through the terracotta itself, if you have to end up doing that, then the chances of breaking one are pretty high. Even if you don't have to drill through the terracotta, you find a mounting mechanism that will work to go directly into the roof, and the terracotta will lock and cover it up. Just by removing them and placing them, you risk breaking them. All right. So basically, you're coming out from underneath that terracotta tile, and then you're putting your racking on it. You kind of have a series of C channels to do that. Flashing on shingle roofs is the most common attachment system that we use. This is how it looks. You drill a hole through the shingle. You use basically a bottom plate, okay, that well, let's back up. You drill a hole that goes either into your blocking or into your roof rafter. You cannot use these into decking. If you don't get the roof rafter, then you end up needing to put a blocking in or a J-bolt in some way, shape, or form. Once your hole is drilled, and you need to drill your hole 50 to 75% of the size of your lag. In other words, if you had a 1-inch lag, you would drill your hole half an inch in size to 3/4 inch in size. You will learn about it in another section, but that is determined on what you're drilling into. Soft woods, 50%. Hard woods, 75%. If you're drilling into pine, 50% size, all the way up to 2/3, so 66%. If you're drilling into solid dried oak, then you're going to want to do a minimum of 66% of your lag bolt size and probably up to 75%. Hey, I've got my hole drilled. It is into the stud or into the blocking. I now am ready to make my attachment. I fill my hole, or I put my I fill my hole with silicone, or I put butyl rubber into my hole, and then I insert my lag bolt or my lag screw to the appropriate depth or torque. Some devices have a torque rating. That's where you will need a torque wrench in order to take the warranty off of you. Hey, the wind blew these panels off. Okay, did you torque them proper? If you don't own a torque wrench, it's really hard to say I torqued them properly. It's one of those tools that is required for installation. Now I torqued this bottom section down in place. I take my foot and I slide my foot under the shingles that are uphill or up roof, and then there's a hole in my foot that allows me to put a bracket in and attach using a waterproof mechanism. In other words, all of the water that flows onto here flows around my foot. All right. If you use these style of roof attachments and you install them properly, you have a very low chance of having a leak. That's my recommendation, is these flashing styles. All right. Questions on this? No, I didn't figure you'd have many. Before starting an array installation, it's a good idea to make sure you have every item you feel you would need. I would also recommend having between 10 and 20% extra on hand at all time. Hey, you need 20 mid clamps for this job. Order 24 of them at least. On your next job, if you order the exact same ones, order 24 of them at least. Here's my recommendation, is eventually you'll have enough of those that you won't need to order them for a job, and it's kind of like a profit bonus for that job. I almost always, even for my own projects, unless I know I've got enough material that I don't need to order that, I order an extra 10 to 20% on everything I do, from plywood to wiring to metal. It sucks to make a mistake, over torque something, strip out a bolt, and your entire project is now in delay because you can't find one bolt exactly like you need at your local hardware store. All right. Mounting hardware. You need to remember to check for roofing attachments with the proper lag screws. Attachments from the screws to the racking. Sufficient racking for the array and extra, including your splices. That's very frequently forgot by novices or amateurs. And then an experienced inspector comes and inspects it. You didn't put your splices in, and they tell you got to pull it all off your roof and put your splices in, and then put it all back on. Hardware to attach the modules to the racking, your grounding clips, your mid clamps, your end clamps, some of the tools. Of course, installation directions. Guys, I know that we tend to be macho man in this industry. If you have not installed this product before, you need to read the directions. And I'm not saying because you're not going to be able to figure it out. I'm saying in the directions, there's oftentimes tricks for installation that will make your life so much easier. Or there are in directions that are warranty required. In other words, it may say that you must torque these to this specification in order for your warranty to be done. You need to do one of those, especially your end clamps. Hammer and or stud finder. Guys, it is insulting to say that to a customer, I'm going to use a hammer to find your studs. A stud finder is a very cheap investment that every job must have. My recommendation for you is you will pull your hair out if you buy a cheap stud finder. Buy the most expensive stud finder that Lowe's or that you can find on the internet. If that thing will take x-rays of your hand, more power to you. Get the best one that you can. I've got one that was about $70. It actually has a screen on the stud finder that will show me where on the screen the edges of the stud are. And yet I think that it could work better than it is. If you've got more than 3 layers of shingles, it won't find the stud very well, Chalk line, roof sealant, portable drill and accessories. Guys, I'll accentuate the word portable. It is extremely important to have a great set of battery drills and battery equipment. Oftentimes, you have the power shut off to your home while you are doing wiring, and how are you going to work if you got the power shut off to your home? If you're doing new construction, oftentimes there's only a limited amount of plug-ins, and you may not have extension cords to reach the 300 or 400 feet from that plug-in to where your ground mounted is. You really, really, really need. I'm videoing. You need something.
I was just going to say, Arthur said that he came by the Merit Center this
Okay,
afternoon.
just let me know if it's here.
Okay, yeah, Connor's going to go and get it.
All right, I got to leave at 2:50, just so you know.
Okay.
So sockets and wrench sets, hand tools, guys, screwdrivers, everything like that. Some basic information about trusses. I assume people know it, but I have to. That's a bad assumption. Almost all trusses are on 16-inch centers or 24-inch centers. I will tell you that as we've gotten cheaper, code has allowed people to use 2x4s on 1-foot centers for many roofing projects. I know it sounds weird, but their math would come out that it would be nearly as strong to cover an 8-foot span using a 2x4 every foot as using a 2x6 every 2 foot or a 2x8 every 2 foot. And so different jurisdictions have different codes. The ones you really need to worry about is if you ever get to a site and they want you to install on a barn and the barn has 4-foot centers. That may not meet wind loading requirements, and I can't tell you what to do. You may need to talk to an engineer in order to solve that problem. Traditionally, 16-inch or 24-inch centers, but let me tell you guys, we're all humans, and these things are not exact. So if you think you can put a tape measure and go from where you know one is and figure out all the rest of them, more power to you. My highest recommendation is you use that to get an estimate where to look with your stud finder, and you use your stud finder to find every single hole that you drill. The wind loading calculations are based on the lag bolt connection to the truss. There's a term called an extraction force, and every lag will be able to provide you what the extraction force of that lag is based on how deep the lag is inserted and what material that the lag is inserted into, i.e. white pine versus red oak. All right. So one method, of course, is to locate the trusses from above. If you have access to the attic, and in the attic you can see the trusses, guys, it's just so much faster to drill your holes from inside the attic. I know that this sounds crazy, but if you have a stud, and the stud is approximately 1.5 inches wide, okay? At the top of my stud here's where my roof decking is. If I come and bring a drill bit from the underneath side and I drill at an angle up through my roof, Once I get the hole that pops out to the top, the person on the top can drill right back down into that stud, and you are guaranteed to hit your stud 100% of the time. You will never miss it. Do you have to have two people to do it? Yes. But I guarantee you, if the first time that you're trying to drill from the top and you drill through over here, now you have to come in and put a blocking in to make that hole you just drilled usable. You will spend more time to do that than to automatically have a guy in there and him go through, drill one hole, move 4 feet, drill another hole, move 4 feet, and drill another hole. It's just oftentimes easier if you have that access. All right. Good stud finders are expensive and not always reliable, even the best ones, guys, even the best ones. Okay, locating the trusses. Alternative, some people do try to use a verification of sound and feel whenever you are tapping on a roof or a wall to locate trusses or studs. Guys, it is highly inaccurate. I'd say that even me, who has done a lot of construction in my life, I will miss about 1 out of 4 times whenever I'm using a hammer to identify where that stud is. And then I'm forced to angle the screw. And if you're forced to angle the screw, then you are really risking a leak if you are putting that into a roof. Now, in a wall, it's not that big of a deal to angle that screw, but in a roof, that's a big no-no. Okay, pilot holes. Here we go. Pilot hole must be drilled to prevent splitting the wood, unless it is a self-drilling screw. If it does not say that it is a self-drilling or a self-tapping screw, then the pilot holes need to be drilled. They need to be drilled 50 to 75% of the size. And once again, softer woods use a smaller pilot hole. Harder woods use the larger pilot hole. It looks like I've got a double slide in there. It's that important. High quality roof compatible caulk should be applied before attaching the mounts to the roof. Seal everything. It is not possible to use too much caulking. It is not possible. All right. You can always come back with a razor blade after it is dried and trim off the excess caulking. Now, it is definitely possible to get caulking in places you don't want to get it. You want a big cleanup on a job? Step on some monkey poop or monkey shit and then walk around a nice metal roof. You're going to track it all over and you're going to come back with rubbing alcohol later on and have to clean every bit of that off. Do not get it in places you don't want it, like solar panels. Don't get it on the solar panels. In fact, I would recommend you never even have solar panels on the roof at the same time that you've got liquid sealant. Put the sealant in every hole that you are looking to fill. Do not assume that the butyl rubber on the bottom of your foot or on the bottom of your bracket will seal well enough. That butyl rubber is to seal the roof to the bracket, not to seal the hole that was drilled where the lag bolt is inserted. All right. Attaching the array. Additional pieces provide a point of attachment to the aluminum. So oftentimes you've got your foot, and then from the foot you'll have a second piece that goes from the foot to the racking. Some racking goes directly to the foot. I do not like that as well. The reason being is that if you don't have anything except the butyl rubber along this edge to seal up, it's going to be a whole lot better if you have flashing going over your foot. That is my recommendation. However, you as an installer will install whatever equipment, according to the equipment manufacturer specifications, that your employer purchased for you to install. Guys, on the back of every panel is a J box. It's a junction box. I think that you've seen them on the back of panels. Sometimes those boxes will stick out farther than the rails of the panels do. You have to make sure that that J box is not touching the racking. So either you need to locate your panels slightly up higher or slightly down lower to ensure that that box is not directly over the racking. Once the racking distance has been determined, it can be attached to the roof attachments. This person is not using a torque wrench. However, many installers require a final torque to be done using a torque wrench. My recommendation is to get either an electric or a pneumatic torque wrench and just put them all on using a torque wrench. It's fast and it's guaranteed to meet the parameters that you need. Module fasteners. We've already kind of talked about these. We have mid clamps and end clamps. Some of the mid clamps and end clamps are also grounding clips. The aluminum frame of the modules slips underneath the edge of the clamps. Guys, there is certain levels of tolerances. If you're putting two things side by side that need to be, parallel, if one of them gets out, and I'll use an example, dramatic, okay, the next one is going to make it more dramatic. So it is very important that you meet the tolerances. You push this panel all the way under the clips and this panel all the way under the clips before you tighten those clips down. This is not a one-person job. In fact, oftentimes it is a three-person job. One person to really be pushing sideways in, while two other people are making sure that they are keeping it up and down in the exact location. Most crews are four-person crews. Somebody always remains on the ground. Always somebody on the ground at all times. That is, interestingly enough, oftentimes the crew lead. They're paid the highest. And then the workers on the roof, three of them are the ones that are handling the panels. And so three people can handle one individual panel very easily. They can manhandle it. They can get it in place. Two people can hold it while one person is putting the module clips on, or one person can hold it while the other two are putting the module clips on, and it goes very quick, efficiently, and most importantly, safe. Three people is always a lot safer than two. Two is required. Okay, wiring the modules together. You always do your wiring after the module has been mounted. In other words, if this module does not have its mounting brackets completely attached in its permanent location, do not wire this panel yet. All right. But as soon as this panel is in place and it's attached, you can totally wire that panel to any other panel that is attached. There are some instances that you must click the panel that you are installing next to the panel that is already installed. But you should not ever attach two panels together that are not mounted. The reason being is if you have one panel that is not mounted and it is wired to another panel that is, the wind catches it and blows it away. It starts to slide off. That one panel that is attached already will more than likely catch that panel and keep it from blowing off or blowing away. If you have a series of them that are attached to each other, you're going to have a domino effect. One panel is going to cause another panel to slide, causing another panel to slide. It is a nightmare. Do not attach panels electrically to each other until at least one of the ones that you are attaching to is solidly mounted. All right. And normally we use MC4s. You may need to cut the existing MC4s off and make the wires shorter. You may need to wire in extending MC4s to extend to another location. But once you get your wiring to the right length, there are wiring clips you need to use to tuck the wire up to the module frame so that it does not rub any of the roof surface. The wiring should never touch the roof. For a lot of different reasons, partially is temperature. Roof surfaces can get pretty hot. You don't want any of the coating of the wires, gonna melt off. Roof surfaces are also oftentimes sharp. Metal roofs have very sharp edges. Shingle roofs, they have a buildup of gravel that as they age, the little pieces of gravel can build up along the wires. You just don't want the wires touching any of your roofing surface. Aesthetic considerations. Now, this is at the very end because it's about the least important. If you have the ability to mount the panels in one location that has more sun, that's where you need to put it. If you look at this right here, most people would say that this is not real aesthetically pleasing. It's got this L, okay? But let's face it, guys, if we put it down here, it'd be in the shade. If we put it over here next to this tree, it'd be in the shade. So the maximum location for solar irradiation is where we're going to locate that. But once we've got it there, we need to have a thorough understanding of the aesthetics. So mounting the array parallel to the roof is almost always going to be most aesthetically pleasing. To have different roof angle versus a panel angle. Number one, you have shading concerns you have to factor in, and number two, you have the aesthetic concerns that a lot of people don't like. Use the roof dimensions to establish the array aspect ratio. Basically, you can fit a certain amount of panels on a certain space, and you can fit one in one way more than another way based on landscape or portrait. In other words, here's portrait. I don't have room for a third, but if I did them in landscape, I may be able to get more panels on my same area. Visually, most people agree that landscape or portrait doesn't matter aesthetically as long as they're all the same. If you have some of them that are one way and some of them the other, you better get your customers' approval before you do that, because that is aesthetically a choice that they may not like. All right. Avoid harsh contrasts in patterns. In other words, if they have a very, very square, if everything about their home is square, try to make a square instead of a rectangle. Okay. If everything about their home is triangular shaped, perhaps consider a triangular pattern. You got 4 panels, and then you got 3 panels. You got 2 panels, and then you got 1 panel. Hey, I just made a triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's almost exactly the number of panels that we frequently put in order. Okay, and so you can do aesthetic changes. It may add cost to the project, but of all the things that customers are willing to pay more for, if the wife sees a pattern she likes and a pattern she doesn't like, she's going to happily add an extra $2 or $3 per month to that monthly payment in order to get the style that she likes. All right. Most important though, guys, I'm going to end on that. You have to avoid shading. That is the primary goal. It does not matter how aesthetically pleasing it is. If you do not take into concern your shading conditions of the location you're at, then it will be a poor design. Nathan, any questions? All right. For those of you who are watching this at home, if you do have any questions about the mechanical installation of our systems, please check your Blackboard and you should find this PowerPoint available. If you've got additional questions, feel free to either email me or catch me in the next class session that we've got. Thank you very much for watching.